All right. So we're starting right here today. Okay. So today is the day that today's harder than yesterday, particularly the homework. Last hour, a student handed her homework in and she's like, that is the worst thing I've ever done. So, she said, I've never felt more stupid. So just keep in mind that this is hard. It's hard for everybody. It's not just hard for you. Try, don't give up, but also don't beat yourself up over it, okay? So when you do your assignment today, there will be a key for it in Schoology, and then I also have a paper key for it up here. So what I told them is get started on the proof, work as much as you can on your own before you look at my key at all. And I'll kind of give you some tips on that as we go through today. So if we look at this proof, first of all, if you're going to do a proof on paper, you have to write out the given, you have to write out the proof, you have to draw the diagram. Using the diagram is so important. It's not just for this chapter, but especially when we get into the next chapter. So what we're gonna do here, we're given step 1, so this is just going to be given. Okay, now, can you guys see what they did from step 1 to step 2? Christian?
Took off the bars and squiggly.
Which is called, do you remember?
Definition of congruent segments.
Very good. Definition of congruent segments. Okay, that is a super common step that we can do to get started, is just take off those bars and squiggly. Now, whenever you guys see two things added together to be one, do you guys remember what I said yesterday to think of? When you have two things added together to be one, what you would want to do is look up at your diagram and see, did they take a segment and break it into parts? And that's what they did. They said PQ plus QR equals PR. And what is that called? When you take a segment and break it into parts? Christian?
That'd be the segment addition postulate.
Very good. Segment addition postulate. Okay. Now, if you look, they want us to do the segment addition postulate again. And if I look here, I already broke up PR, but I didn't break up QS yet. And so I have segment QRS here that I can break up. So I'm gonna say QR plus RS equals QS. QR plus RS equals QS. And again, that's segment addition postulate. Okay? Now, what we eventually want, you can always kind of look back at what you're trying to prove and look at what is it that I'm eventually going to want to know. And what we want to know is that PQ is equal to RS. And right now we're not close to that at this point, okay? So what we're going to do is we are going to use the fact of substitution to do this. So if you guys notice, there's a PR right here, and there's a PR right here, okay? And PR equals this yellow box. So what I can do is I can pick this PR out, and I can substitute that PQ plus QR in for it. And that is what they did right here. Okay? They took out the PR and they substituted that yellow box in for PR. Now, if we look, we also have that QS equals this orange box, okay? And we have a QS here and we have a QS here. So if QS is equal to that orange box, I can pull out the QS from step 2 and I can put this orange box in for QS, and that is what they did right here, okay? Remember too, if you ever need to guess on a proof, always guess substitution, especially like right here in a proof, like after you get those first few steps done, you're probably a good guess to say it's substitution, okay? Now again, we're gonna look at what is it that I want to be equal. And I'm gonna erase these for right now. I eventually want that PQ right here is equal to RS right here. And notice what they tell us. They say to use subtraction. What can we subtract? QR on both sides. You can subtract that away and say then that PQ equals RS. And if you look up above, now we have exactly what we want. The only difference is we need the bars and the squiggly on it. So if I come back down here, I'm gonna say segment PQ is congruent to segment RS, and that is by definition of congruent segments. Now this proof is easier than some of them you're gonna be doing today because they had the left side done for you, and a lot of your assignment is going to be where you do the entire proof. But I just wanna point out, they started with the given. Then they took the bars and squiggly off. Then they split the segments into parts, and then they substituted. And then at the end, sometimes you have to subtract or substitute again. But that is going to be a very common thing to do in these proofs, okay? You don't subtract in every one, but you certainly do the substitution, okay? So now let's go to this one. This one's gonna be harder because of the fact that we don't have any of the statements written for us. So what we're gonna do is we're gonna start out writing down our given. That segment AP is congruent to segment CP, and that is given. And then I'm also in the same step gonna say BP is congruent to DP. I believe this one is in your homework today, so you might wanna make sure you write this down, because then you'll have one of the proofs done, okay? Now, what would you do first? Christian?
Definition of congruent segments.
Yep, take those bars off. So let's do that. Bars and squiggly off. So we have AP equals CP and BP equals DP. And that is definition of congruent segments. All right. Now, I still don't really, I'm not close to anything that I have. I don't have an AB here. I also don't have a CD here, so that means we have to do something else. What was one of the things that we talked about doing?
The first step I did is AP plus BP equals AB with the segment addition postulate.
Yes. One thing I want to point out here, when you guys go to split this segment up into parts, okay, this could either be AP or PA. So you want to look at how did they write that. And the reason is when you're doing this one, I would have called this PB but notice the book calls it BP. And then when you do the whole thing here, the book calls it AB. So we're gonna say AP plus BP equals AB. So AP plus BP equals AB. What is that called? Segment addition postulate. Okay? And in almost every proof today, there's gonna be one in your assignment I'm gonna tell you not to do that with, but most of them you're going to, okay? Now if we look, we still have to break this one into parts. So if I look, this could either be written as CP or PC. Notice it's CP. This could be PD or DP. Notice it's DP. And then the whole thing is CD. So I'm gonna write CP plus DP equals CD. CP plus PD or DP, and the book wrote it as DP, equals CD. Now, for that, that is also segment addition postulate. So you could leave that with step 3, or you could do an extra step 4 and call that segment addition postulate 2. Either way is absolutely fine. Okay, now, if I go back and I want to look, what is it that I want to show as equal? I eventually want that AB, which is right here, equals CD, which is right here. Now, do you guys understand? If you have two equations, does it make sense if these two are equal, that these would be equal and vice versa? Okay, so if these two sides were the same, then I could say these two sides are the same. So what would be really nice, because these are what I want to prove equal, is if I could get this in yellow to look exactly like the one in purple here. So if I could substitute AP and put CP in there, if they're equal, and if I could substitute DP in for BP, that would make them equal. So let's look at doing that, okay? So first of all, I'm gonna try to make AB look exactly like CD, and up above, AP equals CP. So I'm gonna put CP in here. Then DP equals BP. So what I'm gonna do there is I'm gonna take this DP and put that in for BP, okay? So when I rewrite that, I'm gonna put CP first, because I substituted that in for AP, plus I substituted DP in for BP, and that equals AB. I did that because now I have CD and AB the same. What do you think we would call that step? Christian?
Substitution.
Very good. So remember when you do substitution prop, it's SUBST. One thing that I didn't say yet is I have the last page of your test to grade, and one place that I found some kids lost points, you have to number both the left and the right side. Are you okay?
Yeah, I'm good.
Okay. The left side and the right side you have to number, okay? So some kids lost like a point or half a point on a proof for that. You also always have to put property, if it's like subtraction property, addition property. If you didn't do that, you lost some points, okay? All right, now what we're gonna do is look at what we need. And what we need, if you go back and look at the beginning, is we need A, B, and C, D to be the same. I need this and this to be the same, okay? If you look at what both of them are, aren't these two green boxes identical? Okay, so if AB equals this green box, and there's a green box right above it that's the same, do you guys get that I could put AB in for that upper green box? And what I could say then is AB equals CD. What do you think that's called?
That's still substitution.
Yep, it's still substitution. Okay. And the reason I could do that, this is super important, you guys. The reason I could do that is I got these two sides to be identical, so then I know these two sides are identical. Okay? Now, the only thing I have left is to put the bars and squiggly on. So for step 7, I would just say segment AB is congruent to segment CD. And what do we call that again?
Definition of congruent segments.
Very good. Definition of congruent segments. Okay? Now, we're gonna do one that again has the left side done for us. And this proof kind of uses everything that we've learned. It has midpoints, we do segment addition postulate, and we take, maybe we either take the bars off or maybe put them back on, okay? So, first of all, I have two givens. When you notice here, the first given is in step 1, so I just write given for that. The second given is step 3, so I write given for that. Okay? Now, if you remember back to yesterday, I went over this with you guys, that if you ever knew like X is the midpoint of AB, okay, then I would know that AX equals XB. If I wanted to do it with the equal sign, I could do that. Or if all of my segments had that squiggly and the bars, I could write it that way. And one of the things I said is I don't really care which one of these two you use. I typically use midpoint theorem. If you wrote definition of a midpoint, that is absolutely fine, okay? When you have a midpoint in a proof, like we have right now, you're absolutely going to use one of those two things I just showed you. So they say C is the midpoint of BD. If C is the midpoint here, I can say those two pieces are equal. That is what they did, and I can either call that midpoint theorem, or if you rather would do definition of a midpoint, I would accept either of those. Okay. Now, they also tell us that D is the midpoint of CE. So that means this is going to be equal to that. So that's what they did in step 4, and that's the same thing. It's either going to be midpoint theorem, or it is going to be definition of a midpoint. Whenever you're given a midpoint, you have to do one of these two for a step for each midpoint you're given. Okay? Now, what I want you to do is look at step 2, 4, and 5. how did they get step 5 from 2 and 4? Yeah. You could say substitution, that's absolutely right. Anna? A lot of people think that it's subtraction if you had BC plus CD equals CD plus DE and you subtracted CD away. Yep, Christian.
Transitive property.
It's transitive. The ending of this and the beginning of that are the same, so we cross those out and we say the outside two are equal, and that is transitive property. If you said substitution property on this, it's not wrong. Transitive is actually a type of substitution. Okay? Now, we did one like step 6 yesterday. This is not something I do in my proofs, but the book actually does this quite a bit. They took this, and what do you notice they did to both sides? Added CD. So they added the same thing. What do you think that would be called? Yes, addition property. Very good. Now, I have been telling you guys that when you get stuck, take the bars off and break segments into parts. Normally, I would do that up further in the proof, but down when you get to step 7, if you guys see that they're adding 2 things to get 1, you're gonna think of, is that segment addition postulate? And that's why your diagrams are so important, is you need to have those to see if that's what that is. And that first one says BC plus CD equals BD. And that is how they got that. They did segment addition postulate. The second one, they have CD plus DE is equal to CE. And that is also segment addition postulate. So what we're gonna write here then is we're just gonna write segment addition postulate. Okay. Now is when this proof gets a little bit hard, okay? If you look back at this and you look at, like, how did they get from step 6 and step 7 to step 8? What do you think you should think of? You should think of substitution. If you think of substitution but you don't see it, still guess it, okay? You're done with a lot of the things you have, you're looking at it, you're like, gosh, I'm not quite sure what they did here, but this is a place where you would guess it if you don't see it, okay? But here's the deal. Do you guys see how this and this are identical? Okay? If BD is equal to this blue box, can I take BD and put it up in there? Okay? And then if I look, CD is equal to, or CE is equal to this green box, and I have this here that is identical. So I can take that green box out and put CE in there. That is what they did, and like I said, that is substitution property. And then if you look, how did they get from step 8 to 9? Christian?
Definition of congruent segments.
Yes, they just put the bars and the squiggly back on. So today you guys have a worksheet. You don't have to copy down which problems to do from this because it's written on there. And then I'm gonna do number 9 with you guys, okay? So I'm gonna hand this out, but first I wanna show you guys, where I wrote which ones to do is right in the middle of this page, okay? So we're gonna do number 9 together, so just hold off before you move around, and we'll do that one together. Now, here's one thing. Some people like to write the work in their notebook, which is absolutely fine, and then you could just staple that to this, and that would be fine. Others would prefer to write small next to the problem, because then they don't have to write out the given, the proof, and the diagram. So you decide if you wanna write it in your notebook, or if you wanna write it small next to number 9, but we are going to do number 9 together. Okay? All right, is everybody ready? You're either gonna do it in your notebook or on the worksheet. Okay, this one is kind of hard, I will be honest with you guys. So here's the deal. Let's write down our given. So segment HI is congruent to segment TU, as well as segment HJ is congruent to segment TV. That is given. Right? Now, we're doing this one. What can we do? What's a step we can do at the beginning? Christian?
Definition of congruent segments.
And take those bars off, right? So let's do that. If you're doing this on a test, you're getting 2 points for doing this. So as much as you can get down, the better you are. And that is definition of congruent segments. Okay? Now, if you're still not seeing what we need to do, what could you do? What's the other tip that you can do in these problems? Christian?
Segment addition postulate.
Segment addition postulate. So, we have 2 segments that have 3 points. If you're doing this in your notebook, draw the given, the proof, and the diagram, okay? So what we're gonna do here is break this into parts. So we're gonna say HI plus IJ equals HJ. HI plus IJ equals HJ. And that, like Christian said, is segment addition postulate. Now, in that same step, I can break up my other segment, and I can say TU plus UV equals TV. Okay, TU plus UV equals TV. And I can put those both under step 3, or I could have done step 4, and that would also be segment addition postulate. Okay. Now, what I want eventually, if I look up here, I want IJ and UV to be the same. And right now I'm a ways away from that, okay? But what I do know from right here is I know that HJ and TV are the same from right here. Do you guys get it? These 2 sides are equal. Wouldn't that make these 2 sides equal?
Yes.
Do you understand that? Okay, how it would be like explained is they would say HJ equals this orange box. So this orange box you're gonna put in for HJ, and then they would say TV equals this yellow box, and TV is up here, so we can put the yellow box in for that. And that is substitution. So let's do that. Let's write that out. So we put the orange box first. So we're gonna say HI plus IJ equals TU plus UV. Okay, and we use substitution there. So SUBST prop. Make sure you don't just do SUV. I had a couple that did that on the quiz. Now we can look again at what we are trying to find. We're trying to find that IJ right here equals UV, which is right here. Okay, now in the ones that we've looked at so far today, these two were identical and we could subtract them away. What would be really nice is if we could get those two to be the same. If you look up here, right here, they are the same. So what that means is I can either go down and change the HI to TU by substituting it, or I could change this TU to HI by substituting it. Whichever way makes more sense to you. So what I think I'm gonna do, I'm gonna take this TU and I'm gonna put it in right there. TU equals HI, so I'm gonna take that HI out and I'm gonna put TU in there. So TU plus IJ equals TU plus UV. And what did I do there? I substituted again. Okay. Now, you look up above again and look at what is it that we want to say is true. We want to say, or equal I should say, we want to say that those two are equal. Can I get rid of those TUs now? How? Subtraction. So what I can say then is I can say IJ equals UV, and that is subtraction prop. Okay, now if I look up above, the only thing I have left is I have to add the bars to that. So I could say for step 7 that segment IJ is congruent to segment UV, and that is by definition of congruent segments. Now, I have 2 hints for you guys for your worksheet, and hopefully will save you a little bit of time. Next to number 19, write that there's only 2 steps. And then I'm gonna say, think transitive. I just don't want you to do a whole bunch of steps and then realize you didn't have to do that. So 19's only 2 steps. The other hint I have is for number 20. It's very similar to number 9. So when you get to number 20, if that one's hard, go back and look at how we did number 9, and that's the one we just finished here, and that should help you. I have a key over on the podium that you can take pictures of, and I have a key, I believe, that's linked in the snapshot that has the problems done. But I would try to do